Hi, my name is Yu Chen, and our group consists of three people. First is me, and my ID is 748663, and my second partner is Da Huo. His ID is 791094, and my third partner is Bing Xie. His ID is 741012. Okay, let's start to our presentation now. In today's context of technological revolution in robot and artificial intelligence, the latent needs in this area is really enormous. In this video, we will mainly state a robot localization and navigation system through a series of fictional researches, which consist of a composed global localization system in intelligent space based on Monte Carlo particle filter algorithm and Wi-Fi fingerprint localization and navigation system based on K-means visual navigation and ultrasonic navigation. This system can solve the global localization problem in which the initial pose of service robot is unknown and the robot pose is determined according to the sensor information, and it can navigate the robot to go through some hostile environments as well. On the other hand, not only the proposed system can realize zero configuration and loose coupling between ROS service robot and intelligent space so that the precision of the global localization of the robot will be improved effectively, and the iteration time will be reduced fairly. But also, it can sustain fairly high adaptability and stability even working in a harsh environments, such as a cluttered office or a greenhouse with high temperature or humidity. Okay, my second part will be the usage scenarios. This system is suitable for several scenarios. Normally, it can be used in floor mopping robots, especially the robot working in cluttered office environment. So general consumers will be underlying clients. On the other hand, it can be used in some particular or hostile environments. For example, it can be implemented in greenhouse robots, and it can also help mine disposing robot to move through complex uh, terrain or help search and rescue robot in dealing with earthquake rescue. Therefore, military and fire brigade may become the potential clients. Okay, now it's time for our partner Bing Xie to introduce the second part.
This framework can be divided into three parts: intelligence space dispatch system, Wi-Fi collector system, and inner system. Intelligence space dispatch system and inner system is like human's brain. Wi-Fi collector system is like human's hands and feet. Intelligence space dispatch system could send signal to the controller, uh, then to the Wi-Fi collector system. Then Wi-Fi collector system could execute collecting data. The receiving data will be first stored in database, then the processed by neural network. Finally, dispatcher will give instruction on implementing localization and navigation. Now I will introduce the localization part for this system and its relevant technology. The design of global localization system based on Wi-Fi fingerprint localization and particle filter algorithm, which is mainly composed of two parts. The first part is take the advantage of BP neural network algorithm to track the robot with coarse location. Second, based on coarse location, scatter particle points and laser scanning data, then get the accurate location. For coarse localization, Wi-Fi fingerprint localization based on BP neural network algorithm. It has high supervised learning ability and then can effectively update the Wi-Fi strength model in the intelligence space. Meanwhile, BP neural network has a well fault-tolerant property. To be specific, the BP network, the BP neural network can continue to work even if some IP points uh, in the intelligence space model happen to be breakdown. Um, the general training process can be divided into five steps as shown in the figure. Accurate localization uses particle filter localization based on Monte Carlo algorithm. Since the precision of Wi-Fi fingerprint localization algorithm is about 1.5 meter to 3 meter, the Wi-Fi fingerprint algorithm cannot meet the requirement of service robot. More accurate localization mechanism should be applied to these service robots. The localization process can be divided into two stages, predict stage and update stage. In the predict stage, when the coordinates and the error range can obtained from the previous course localization. Then initialize the sample set according to the dynamic model. The sample set could be obtained to express the prior property density distribution formula. In the update stage, service robots obtain the latest device information, use the prior probability density distribution formula to update the weight value of the sample. Then normalize the weight. After that, the updated sample could be approximately expressed a posterior probability. The purpose of this resample process is to increase the number of larger particles in the range of Wi-Fi fingerprint coarse localization. Iteratively, um, iteratively execute above procedure and update the sample set. The robot localization with maximum weight in the sample set will be used as estimate value for service robot. Now let my partner Da Huo to introduce his navigation part.
Hi, so I will introduce the main method of the navigation, um, which are the variable navigation based on the k-means and the ultrasonic navigation. So these two methods should be combined with each other so that the system could navigate the robot smoothly. And the first step should be the image capture, and it's done by the camera in front of the road. And the second step should be the obtain of the color interfaces. The system uses HSI space to get the color components and separate the image into several main parts. After setting a threshold for the color components, the program uses k-mean algorithm to separate the image into several clusters, and there could be a clear partition for the road and barriers besides. The robot could get a clear path to the destination, but there should still be some counters and barriers near the road. The navigation system should get the clear distance to the barriers in case of striking, so the system uses an ultrasonic navigation algorithm to avoid the barriers. The ultrasonic sensor could detect the distance to the barriers by getting the time gap between sending and receiving the ultrasonic. So both of these navigation methods have their own advantages and disadvantages. So the best method for the navigation is to combine them together so that the system could get a clear path to the destination and avoid the barriers smoothly. So come to the summarize. Based on the structure of the whole system, the system is separated into three different parts, which are the Wi-Fi collector system, intelligent space spectral system, and an inner space consisted of localization and navigation model. These three parts is used for the communication, location, and navigation. So the system is widely used in the indoor and outdoor navigation domains, such as the moping robots and the mines removal robots. And the system could have a great development prospect. So that's all. Thank you.